Alright, so here we have two products, P1 and P2, and the cost of these two products are given by 2 rupees and 3 rupees respectively. Now the question says that the production process requires two types of resources, labor hours and machine hours. So labor hours correspond to the people working, and machine hours correspond to the machines running. Okay, so whenever you have resources, that means there will be some constraints, because resources are always limited, right? We do not have unlimited resources. Okay, so that being the context, let me write, we have labor hours and machine hours, so LH and MH respectively. And for producing say 1 unit of P1, okay, I require 2 labor hours and 1 machine hour. And to produce 1 unit of P2, I require 1 labor hour and 3 machine hours. Okay, so that is the context. Now consider this case. Suppose we have the product P1, okay, and I want to produce 1 unit of P1. The labor hours I require is 2 units, and the machine hours that I require is 1 unit. Now what does that mean? That means that 10 units if I want to produce, then I will have to spend 20 hours of labor hours and 10 hours of machine hours. So in general, I can say that if I want to produce X units of the product P1, I have to spend 2x labor hours and say 1x machine hours. Similar thing I can do for the other product also, right? So for the product P2, if I produce only 1 unit, I have to spend how much labor hours? 1 labor hour and 3 machine hours, right? So in general, if I want to spend X units, or if I want to produce X units, I have to spend X labor hours and 3x machine hours, right? Okay, so let me make it Y, so that otherwise there is a notational clash. So instead of X units, I'll write Y units of P2. I need Y labor hours and 3Y machine hours. Okay, alright, so now we also have constraints which are 80 hours and 90 hours respectively for labor and machine, right? So what is the total labor hours that is spent? If I produce X units of P1 and Y units of P2, the total labor hours would be 2x plus 3y, right? So let me write that down. So let's assume the units produced are X and Y respectively. So the total labor hours would be 2x plus 3y. Sorry, it would be 2x plus y because LH is 1, right? Similarly, for machine hours, we will have x plus 3y, right? Now the constraint says that the labor hours are limited to 80 hours. So the total labor hours, which is 2x plus 3y, will be limited to, or will be less than equal to 80. Similarly, for machine hours, we have the constraint that it should be less than equal to 90. So I can say x plus 3y will be less than equal to 90. So given all of that, we also have an additional constraint, which is that x and y are non-negative, because see, these are units produced, right? So you cannot produce -1 or -2 units, right? It always has to be non-negative. It has to be positive, or it can also be 0. Okay. And here it says, see, all of the options have got minimization, right? And typically when the question says cost, we often tend to minimize it. Although, actually in the problem, it should be price, okay? Because see, if you're producing two products, okay, you'll be interested in selling it, right? And then you want to compare how much you are obtaining. Okay, so you have to maximize your profits. But let's go with the notation. So it says cost, so the total cost would be 2 times x, which is 2 is the cost for P1 and 3 is the cost for P2. So it will be 2 times x plus 3 times of y, right? That will be the total cost, and we have to minimize it. That is the idea. So the problem will be minimization of, see, all the options have minimized, so let's minimize it, because otherwise if it has been priced, then I would suggest to maximize it. Okay, so minimize 2x plus 3y such that 2x plus y less than equal to 80, which is the constraint on labor hours, x plus 3y less than equal to 90, which is the constraint on machine hours. So this is the correct option, which is the second option, right? Alright, so now let's look at the second question, which says find the minimum cost price of the products. Okay, so since this is a two variable problem, we can start off by drawing the graph of the constraints and the objective function, not of the objective function, but definitely of the costs, right? Or the constraints, right? So we have to draw the line of 2x plus y equal to 80 and x plus 3y equal to 90, right? So now how will we do that? First of all, for the first one, 2x plus y equal to 80, first consider the case when y is equal to 0, right? If y is equal to 0, then 2x will be 80, that means x is equal to 40. Now again, if I put x is equal to 0, I will have y is equal to 80. Now the line 2x plus y equal to 80 will be nothing but formed by joining these 2 points, okay? Similarly, we can do it for the second equation also. Alright, so now if I want to plot the second equation, x plus 3y equal to 90, first I put y is equal to 0, then x will be equal to 90. Now again, if I put x is equal to 0, then 3y equal to 90, y is equal to 30, right? And now the line x plus 3y equal to 90 is formed by joining these 2 points, okay? So this is the line. Now again, what do we have? We have as inequalities, we have that 2x plus y is less than equal to 80, right? So the region, which is region of points where 2x plus y is less than equal to 80, is this particular region, right, which is shaded by blue, okay? Similarly, for the second equation also we can say that x plus 3y is less than equal to 90, which means the shaded region is this. Now the required shaded region which satisfies both constraints is the intersection of these two regions. Alright, so now the points which satisfy both the constraints, that will lie in the shaded region, the region shaded in yellow, okay? Now this shaded region, or this is also known as the feasible set, okay? This has 4 corner points, right? So because and moreover, observe that this is actually a convex set, right? Okay, so it has got 4 corner points which are at 0 0, 40 0, 30 0 and some other point, okay? We will find what that is, but before that, let's look at this particular result. If we have an optimal solution, okay, when I say optimal, it means either maximal or minimal, okay? Observe, I'm saying maximal and not maximum, because maximum would mean that it is unique, right? But in this case, it need not be unique. There will be other points also where it is attaining the same maximal or minimal value. But the idea is that if there is a optimal solution, then it will occur at one of the corner points, okay? See, I'm not saying that it will only occur at a corner point. It can occur at a non-corner point also, but it will also occur at a corner point. So that is important, right? If you need more clarity, you can let me know in the comments down below. I can even start a another series of lectures on convex optimization, okay? But as of now, that is not required. Alright, so whenever we have a problem like this, what we have to do is that first plot the convex region, find the corner points, and then evaluate the objective function. What is the objective function here? 2x plus 3y. So evaluate the objective function at each of the corner points, okay? So that is what we have to do, and from those, whichever will be maximum or minimum, that will be chosen, okay? In this case, we are asked for the minimum cost price, okay? So again, this cost price is a very dicey term, okay? Anyway, but we have the points 0, 0, 40, 0, 0, 30, and the other point is actually the intersection of two lines, 2x plus y equal to 80 and x plus 3y is equal to 90. Now, if I solve for this, let me multiply the second equation by 2, I will obtain 2x plus 6y equal to 180, right? So now if I subtract the first equation from the second, I will have 5y is equal to 100, which means y is equal to 20, right? So if y is equal to 20, then from the first equation I can say that 2x will be equal to 60. That means x is equal to 30. So I'll have 30 and 20 as the x and the y coordinates of that point, right? Which is the intersection of these two lines. Okay. So now what we have to do, we have to evaluate the objective function at each of the corner points. So at 0 comma 30, if I evaluate it, so it's what, 2x plus 3y. So it will be 2 into 0 plus 3 into 30, which is equal to 90. Now if I evaluate it at the second point, which is 0 comma 0, I'll have 2 into 0 plus 3 into 0, which is again equal to 0. Now I will have in the third corner point, which is 40 comma 0. So that would be 2 into 40 plus 3 into 0, which is equal to 80. Now at the fourth point, which is 30 comma 20, the objective function value would be 2 into 30 plus 3 into 20, which is 60 plus 60, which is equal to 120, right? So we can say that the maximum value is 120 and the minimum value is 0. Now observe that in the, I think in the answer key initially it was 80, I think later on it was clarified, because the company actually has an option to produce nothing, okay, and that is the most profitable option for the company. That is what turns out, okay. Alright, so in this question, let's look at the first option. It says we have a garden, right, with boundaries being at 200-meter circle and the outer boundary is 300-meter circle, right? So the garden is this shaded region, okay. Now consider 2 points, okay, here and here, and draw a line in between them. So the line actually, observe that the line actually goes out of the garden, right? And whenever this kind of a phenomena happens, it means that the set is not convex, okay? Because for any two lines, we want the line to be inside the set. Now let's look at the second option. It says above the x-axis, radius of 10 miles from the origin, okay? So this is like a semicircle. But here you observe whichever 2 points you take and draw a line, okay, inside the. So 2 points should be in the set, okay. So here the line never goes outside the region, right? Which means that this is actually a convex set. Now let's look at the third case where this is actually a triangular region, right? Again, in the triangular region, you take any 2 points, join them with a line, the line stays in the region, okay? So the line never goes outside the triangle. That means this set is also convex. Now in the fourth path, it's not very clear what kind of region they are indicating, but let's say this is this particular region, okay? Let me shade it, okay? So this is actually a line segment, okay? So so you take 2 points, join them, the line goes out, right? So the line goes out of the region. But what is the region here? The region is nothing but it is a line segment, or you can say it's a joining of two line segments, okay? So this is also not convex. In this question, we have to check if the functions are convex. So fx is equal to x square minus 3x plus 2 multiplied with x square minus 7x plus 12. So this can be written as x minus 1 into x minus 2, and the second term can be written as x minus 3 into x minus 4. So now if I plot it, it will be something like this: 1, 2, 3 and 4, and then the curve will look something like this, okay? So now observe that there is a peak on this part, right? So this is actually a peak, okay? And whenever we have a peak, that means that the function is not convex, okay? And if we have a trough, that means it is convex. So the first option is not convex. Now let's look at the second one. Before that, let me also say that we can also take double derivative of f and see that if it is always positive. If it is not always positive, it means it is not convex. You can try it out by yourself if required. In the second option, we have that fv is a vector, okay? V transpose av. Now the derivative with respect to v will be a plus a transpose multiplied with v, and the double derivative will be a plus a transpose, which is nothing but 2a because a is symmetric. Now this can be written as 4, 2, 2 and 4. Now observe that the leading coefficient 4 is positive and the determinant is 8 minus 4, 4, which is again positive. So we can conclude that the double derivative of the Hessian matrix is positive definite, which means that f is a convex function. So in this case, f is convex. So in the third option, we have that x square plus y square plus 3. That is a function f. So the gradient will be nothing but the vector of partial derivatives, right? So it will be 2x and 2y respectively. Okay, so now we also have to look at the double derivative, right, which is the Hessian. So the double derivative will be, so we have to take the derivative of 2x and 2y separately, okay? So 2x with respect to x is 2, 2x with respect to y is 0. So similarly, we have that 2 is a positive, the leading coefficient is positive, and the determinant is also positive. And similarly, as the previous example, we can say that f is again convex. Now let's look at the last example, which the case is actually similar to the second example. Okay, so we can directly say from here that the double derivative of the Hessian is equal to 2 times of a, which is nothing but 4002. Again, the leading coefficient 4 is positive and the determinant is 8, which again means that f is a convex function in the last case. So this function is also convex. Alright, so here we have a farmer who needs to do some fencing nearby the river. So the fencing area is like, the fencing region is like shaded. Okay, so it will, let's consider it x, y and y. Okay, so what is the total fencing? The total fencing will be x plus 2y. Okay, because along the river you don't have to do fencing, and the total area will be xy. So the problem is actually to maximize xy, which is the area, subject to the condition that x plus 2y is less than or equal to 120, right? Because it's given that 120 meters of fencing. Now if we consider the Lagrangian, that will be nothing but xy plus lambda times of x plus 2y minus 120. So as per the Lagrangian multiplier method, we take the derivative of this Lagrangian with respect to x, which will be y plus lambda. Set it equal to 0, we will obtain y is equal to minus lambda. Now we also have to take derivative with respect to y, so we obtain x plus 2 lambda equal to 0, which gives us x equal to minus 2 lambda. Now we also have to take derivative with respect to lambda and then obtain x plus 2y minus 120 is equal to 0. Now replacing the value of x and y as obtained above, we will obtain minus 4 lambda minus 120 is equal to 0, which means lambda is equal to minus 30. Now we can put this particular value of lambda in x and y and obtain y to be equal to 30 and x to be equal to 60, right? So this is the optimum values. Okay, now so the maximum area will be nothing but 16 to 30, which is 1800. So first let's recall Chebyschev inequality, which says that the probability of x minus mu bigger than equal to k is less than equal to sigma square, or the variance of x divided by k square, right? So this is what Chebyschev inequality says. Now we have to apply this inequality on the particular question. Now observe that we are given mu is equal to 70 and sigma is equal to 8. So we can say that the probability x minus mu modulus greater than equal to, so instead of k, what do we need? See, k is given to be 16 units. Okay, it's given there. Determine the maximum probability that x will deviate from the mean by more than 16 units. So that means k is equal to 16. So we can say probability x minus 70 is the mean, greater than equal to 16 is less than equal to 8 square by 16 square. Now 8 square by 16 square is nothing but half square, which is equal to 1 by 4, that is same as 0.25. Alright, so here we have a data set and we have to compute the loss function, which is nothing but 1 by 5 times of summation I running from 1 to 5, the predicted value, which is x1 plus 2 x2 minus 2x2 plus x3 and minus of y, right? So we have to do this for each data point. So let's compute it for each of the data points. For the first data point we have 2 plus 6 plus 4, which is equal to 12, and then for the second data point we have 3. For the third data point we have 10, and then minus 5 and then 5, right? Now we also have to compute the loss squared, which means the difference between the predicted and the actual value, which is x1 plus 2x2 plus x3 minus y whole squared. So the first data point we have 9. Similarly, we have 1 for the second data point, 9 for the third data point, and 1 for the fourth data point, and 1 as well for the fifth data point. Now we have to take the sum of all this. So we have to do 1 by 5 times of 9 plus 1 plus 9 plus 1 plus 1, which is 21 by 5, which is equal to 4.2. Alright, so for this we'll use the fact that if x follows normal mu sigma square, then if you make a transformation a plus bx, that will follow normal a plus b mu and b square sigma square. Okay, now this can be proved very simply. So using this we can say that u follows normal, so it will be 2x minus 3y, so 2 into minus 1 minus 3 into 1, right? That will be the mean, and the variance will be 2 square times 11 plus 3 square times 9, right? So that is nothing but, you can say u follows normal minus 5 comma 125. 125 is the variance. So now we have to find the probability that u is bigger than 2, right? That means u minus negative 5 by under root 125 will be bigger than 2 minus or 2 plus 5 divided by under root of 25, right? So now I can rewrite this as the probability z bigger than 7 by under root 125, where z follows normal 0, 1. So here we use the fact that if u is some normal random variable with mean mu comma sigma square, sigma square is the variance, then u minus mu by sigma will follow the standard normal distribution. So this now can be written as probability z bigger than 0.62. Now we have to, so this is nothing but what? This is nothing but the cumulative density function corresponding to the point negative 0 comma 62. Now how did we come across this fact? Now observe that if you consider the normal distribution, okay, it is actually symmetric. So the area on the right is same as the area on the left. So we can say that the area, the shaded areas, okay, these both have the same area, which means the probabilities are the same, right? So what is this? This part is probability z bigger than 0.62, and this part would be probability z less than minus 0.62, which is nothing but the CDF of minus 0.62. Now consider a square matrix of order 3, okay, such that trace is 3, determinant is 2. Now we will use the fact that the trace is nothing but the sum of eigenvalues and determinant is nothing but the product of eigenvalues. So using this very simple fact, we can conclude, and it's also given that 1 is one eigenvalue, which means 1 plus lambda 2 plus lambda 3 is equal to 3, the sum of the eigenvalues, and 1 into lambda 2 into lambda 3 will be equal to 2. So what we have to find out? We have to find out lambda 2 and lambda 3. Now using basic idea about quadratic equation, okay, what we can say is that lambda 2 and lambda 3 are roots of some quadratic equation. And how will we form that quadratic equation? It will be x square minus sum of the roots, okay, sum of the roots multiplied by x plus the product of the roots. Now this can be written as x square minus, so sum of the roots is lambda 2 plus lambda 3 into x, and the product is lambda 2 into lambda 3. Now this can be written as x square minus 2x plus 2. So by Sridharacharya's formula, we can say that x is equal to 1 plus minus I. So what are the eigenvalues? We already have 1. Now we have got 1 plus I and 1 minus I. So we can say that the third option is correct. The fourth option is wrong. Okay. We know that. And the second option is also wrong. Why? Because all Hermitian matrices will have only real eigenvalues, and in this case we have already got a complex eigenvalue, right? So in fact symmetric matrices also have only real eigenvalues, so the first two options are not correct. Now the last option is correct because if we have three distinct eigenvalues, that means we have three distinct and linearly independent set of eigenvectors. The moment we have linearly independent set of eigenvectors, that means, and we have three of them, right, which means that we have an eigenbasis. That means it is diagonalizable. Alright, so in this question we have GP is equal to summation of, I run from 1 to 10. So the norm squared can be written as P minus Xi times, or transpose times P minus Xi, right? So now I can expand this as P transpose P minus Xi transpose P minus P transpose Xi minus Xi transpose Xi. Now let me take the derivative of G with respect to P. So I will get 2P minus Xi. So this, which is nothing but 2P minus 2 times of Xi. Now I have to solve for this, and in fact I have to, let's solve for this by equating this to be equal to 0. If I equate G prime P equal to 0, I will get P is equal to summation of Xi divided by 10, which is nothing but the sample mean, right? But now we do not know if this is a maximum or a minimum, okay, if this is a maximizer or a minimizer. For that we have to do the second derivative test. So if I do the second derivative, I will get 20, which is positive, which means that this particular value, the sample mean, is a minimizer of GP. So at this point GP will be minimum, okay, and that is exactly what the question says, right? Now let us see. So it is given to us that this particular value where it is minimized is nothing but equal to 403, right? And we are asked to find what will be the sum of all these values, right? So we can say summation Xi is equal to 40, 0 and 30. So the second option is correct, okay? Now let's compute, now we have to compute the distance of this particular point, okay, summation Xi from the origin. So we know the distance of the origin is nothing but the square root of the sum of square of the individual components, which is 40 square plus 0 square plus 30 square, uska square root, right? Now that will be nothing but, let me take 10 square out, okay? So I can write this as 10 times under root of 4 square plus 3 square. Now we know under root of 4 square plus 3 square is 25. So the answer is 50, right? So we can say that the second option is correct as well as the third option is correct. Alright, so there are a few basic things that we know about PCA. The first one is that it's obviously used for dimensionality reduction. And how does it do it? It does that by maximizing the variance of the projections, right? So we take the projection of every data point into some smaller dimensional subspace and take the variance of the projection. And it can also be viewed as minimizing the reconstruction error, right, of the data points. Now it turns out that both of these ideas are equal, okay, and you'll get ultimately the same result. So the first option is correct, the last is wrong because it has to be minimized, and the third one is correct and the second one is wrong. Alright, so here we have to find the conditional distribution x given y. So the conditional distribution x given y is nothing but the joint probability distribution f of x comma y divided by the marginal distribution of y. This is the definition. So let us find out the marginal distribution of y. So that is nothing but you have to integrate over all possible values of x, right? So for that, observe that this gives the bound x is less than equal to 1 minus y. So we can say x is running from 0 to 1 minus y times, and what is the integrand? The integrand is f of x comma y dx. So which can be rewritten as 0 to 1 minus I 18 times x square y square into dx. Now 18 and y square are not dependent on x, so let me pull that outside. Now I will obtain x cube by 3 from 0 to 1 minus y. So this can be written as, let me remove 18 by 3 and write it as 6. So 6 times y square times 1 minus y whole cube. That is the idea. So this is the marginal distribution. So now let us look at the conditional distribution. The conditional will be the joint divided by marginal. So the joint is 18 x square y square divided by the marginal, which is 6 into y square into 1 minus y whole cube. That will be nothing but 3 times of x square divided by 1 minus y whole cube. Now remember one thing, we have a condition on x. The condition on x is that x should be less than equal to 1 minus y. So 0 less than x less than 1 minus y. So the second option is correct. Now in the second question, we have to find probability x less than half given y is equal to half. So this is actually nothing but you have to integrate from 0 to half, where x running from 0 to half, and you have to integrate for the probability distribution function of x given y, which we have already obtained. So inside we will have f of x given y, and for y we have the value half times dx, right? Now let us integrate it 0 to half. Instead of that, instead of the integrand, we will write 3x square by 1 minus y whole cube, which is 1 minus half whole cube, right? Now let us pull out 3 and 1 minus half whole cube. We can say it is nothing but 3 divided by 1 by 8 times integral of 0 to half x square dx, which is nothing but x cube by 3 from 0 to half. Now this will be nothing but equal to 1, right? So we can say that the answer is nothing but 1. Alright, so we have to find the null space of A, which means we have to find all vectors which are mapped to 0 under A, which means we need to solve for, say for example, x comma y comma z, where A times x comma y comma z as a vector, okay, that is equal to 0, right? That is what so x comma y comma z is nothing but the null space. So we have to solve this. So we will use the most common method, which is called Gaussian elimination, where we write A and the target matrix, which is the target vector, which is 0, and then we use row reductions to convert this matrix into a row reduced echelon form. So let's do the conversions one by one. So starting with, we will replace row 2 by row 2 minus row 1, or twice of row 1, okay, so that it becomes 0, okay. So in the second row you will have 0 minus 1 minus 2, and the third row you will have 0 1 2, right? Again, the vector 0 on the right hand side, that will not change. In the second step, let us replace R3 by R3 plus R2. So the R3 will be totally 0. So it will be filled with zeros, right? So now let us write the equations properly. So what are the equations that we have? Now we will get x minus 2 times y plus 3 times z is equal to 0, and minus y minus 2z equal to 0, which means y is equal to minus 2z. Okay. So I accidentally wrote z instead of 3z, so let me write it properly. So from the first equation, I can say that x will be equal to minus 2y minus 3z, which is minus 2 times of, instead of y, I'll have minus 2z again, right? So that will ultimately turn out to be just z. So now let's write xyz as a vector. So z will be just z. Instead of y, I can have minus 2z, and instead of x, I will have z, right? So that is nothing but z times of 1 minus 2, 1, which means this particular null space is nothing but the span of the vector 1 minus 2, 1.